Welcome back, Physics 30. This is the last video in the Part 2 booklet. So we left off with ammeter. So if you look at the unit there, ammeter deals with the unit of amps, which is electric current, of course. So you can think of it, it measures how fast the electrons are traveling, charges per second. So to have that, to measure that, we have to have it hooked up in series. Part of the path itself is all the electrons have to go through the device, so we can see how the current flows through each of the device. Okay, so it needs to experience all the current going through the device, so that's why it needs to become part of the path itself. Okay, lastly, if we look at the Earth itself, we say it has a potential difference of 0. It has a surplus of electrons, surplus protons, etc. So if we do have a charged object, such as a Van de Graaff generator, the big silver ball that you saw at the Science Center, if we transport a bunch of electrons to that ball, it would become electrically charged negatively. And of course, if we wanted to discharge those electrons, connect it to ground, and they would go immediately to the ground. Or if I had stripped off all the electrons there, hooking up to the ground would cause electrons to go from the Earth to there to again neutralize it. So grounding, in effect, neutralizes the object itself. Okay. Number 16 here, there are further questions you could look at in the duotang, but we did the highlights anyway of that duotang. So lastly, the vocab here, direct current, electrons flowing in one direction. So here I just have a picture of electrons flowing through a wire to the right-hand side of the page, sorry. Alternating current, electrons reverse direction in the conductor, so you can almost think of them as shaking back and forth, giving off energy. Electric field lines, a region where an electric force is experienced, just like around the Earth, we experience a force due to gravity, it pulls objects inwards towards the Earth itself. The electric lines of force are used to represent the existence and the strength of the electric field. With the arrowheads, it also indicates the direction those fields act. And the direction shows where a small positive test charge would go if it was brought into this area. So positive test charge, a small charge used to determine the existence, strength, and of course also direction. So you may want to just add the word direction onto both of these parts here, since I didn't. So if it's a positive object, field lines go away from the object, because what would happen to a test charge, a positive test charge? It would be repelled. Whereas a negatively charged object, a positive test charge would be attracted to it, so those field lines go towards the negative object. Electric potential difference, the amount of work done per unit of charge required to move from one point to another. So if I have this negative charge here, I'd have to force it to move to the right, because it wants to be attracted to the positive plate, repelled from the negative. So I'd have to actually exert a force doing work per unit of charge. That would be the difference in potential. Schematic diagram, a diagram which represents the components of a circuit and how they are connected. So a battery here, the negative and positive pole. A switch, if it's broken here, that could be used to determine what a switch looks like. And then, of course, if I close that, it's connected, goes through a bulb, etc. Electric circuit, a battery connected to a device by a wire. Ammeter, of course, measures electric current in a circuit. It has to be part of the path itself. And what I should have had on this list, but I didn't, so we'll just insert it here, is voltmeter. Measures the difference in potential across a device. So measures energy before and after, and you get the difference as I noted here. Okay, so ammeter, voltmeter, just slide that in there. Lastly, grounding, object connected to the ground and results in a potential difference of 0. So this is the symbol used for grounding. So if I had something that has electron deficit, i.e. it had all its electrons stripped and it's therefore positively charged, connecting it to the ground supplies those electrons in order to neutralize it. Or if I have an electron sufficient object, connecting it to the ground will get rid of those extra electrons again, making it electrically neutral. Okay, there we have it. So that is the third and last video for this second booklet. We'll see you again.